Kerbal Classroom. Welcome to class.
Today's episode is 3 ways to get to Minmus.
Let's talk about getting to Minmus. Minmus is the second moon of Kerbin. It orbits at 47 million meters and has an apoapse and periapse that are the same, which means it's perfectly circular. It has an orbital inclination of 6 degrees, argument of periapsis of 38, and longitude of ascending node of 78. Let's talk about what these three things that I just mentioned are: longitude of ascending node, argument of periapsis, and orbital inclination. If you look on Wikipedia at argument of periapsis, you can find this handy chart that basically talks about orbital planes and different vocabulary. If you have two planes that meet, there's a line at their intersection. The longitude of the ascending node is the point where the two orbits meet, the orbital planes meet, where your current orbit coming up into it meets. And the descending node is when you're coming down and the two orbital planes meet. The argument of periapsis is the angle between the ascending node line and the line from the center of the orbits to your periapsis or closest approach. The longitude of the ascending node is the angle between some reference direction and the ascending node. So in the case of Minmus, the longitude of the ascending node is 78 degrees. So there's a point from the star that Kerbin rotates around called Kerbal to some direction, and the rotation around Kerbin from the reference direction at 78 degrees is where the ascending node of Minmus and the equator of Kerbin meet. The argument of periapsis in the case of Minmus is kind of useless because it's a perfectly circular orbit. There's almost never such a thing as a perfectly circular orbit, and so you can always find this to be at least partly useful. Okay, let's look in game at how some of these orbital parameters actually map to how we see things. So I've brought up Flight Engineer, and I've modified the orbital HUD to include the things that we were talking about just now. And you can see that I've selected Mun as my target. Mun is perfectly equatorial and circular, and the argument of the ascending node, where this blue orbit's orbital plane meets Mun's orbital plane, is marked with this line from here to here. And you can also see the angle of the relative inclination difference is 41.6 degrees. The longitude of the ascending node is 246.5 degrees, and so that means that if we're looking straight down on Kerbin and we had a clock, or rather a compass with 360 degrees, this is pointed at 246 degrees. So 360 must be something like this. And so this would be 90, 180, 270. Oh, I think I'm off by a little bit. 0 would be here. And this is 246. Now, the orbit that I'm currently in is fairly circular. Let's switch to this polar orbit. And you can see that the periapse 132 kilometers and apoapse 416 kilometers, that this is definitely the closest approach. And I've also selected Mun. The ascending node is over here. You can see that I'm almost perpendicular to the orbital plane of Minmus. I'm very polar in my orbit, and the angle from here to the center and then out to the periapsis is 67 degrees. So this angle right here. If I was to come back around here and burn a little bit longer so that my periapse is more close to the North Pole. Sorry, I have a cold. If I was to burn, watch the angle of periapse. It's coming closer to the North Pole and is getting closer to 90 degrees. The longitude of the ascending node is not changing because I'm not rotating the circle around the North Pole. That would change my ascending node, longitude of ascending node. And remember, the longitude of the ascending node has nothing to do with the longitude and latitude on the surface of Kerbin. It is from the Sun out to a particular reference point. So now you can see the periapsis is getting closer to the North Pole. It's at 77 degrees. If it got all the way to 90 degrees, that means that it would be the very peak on the z-axis of the angle from the ascending node to the center of your orbit, or the barycenter. Barycenter is where you're actually orbiting around. But since it's an ellipse, referring to the center is kind of wrong. Okay, so now we're at 81 degrees, argument periapsis. So anyway, that is when if you're playing in career mode and you get a contract that says, hey, I want you to bring a satellite with these things on it out to a particular orbit, they'll describe to you apoapse height, periapse height, the angle, the longitude of the ascending node, and the argument of periapsis. And Minmus is out at 46.6 million meters out, and it has a 6-degree inclination, and the rotation of the orbit, the ascending node, is out at 78 degrees. So it is different than Mun because it is on an incline, and so you have to worry about, if you were to bring out your periapsis and you are on an elliptical orbit, you would come out under or over Minmus. Here, I'll show it like this. So if you were on the same orbit as Mun and you were in a nice equatorial orbit and you brought your apoapse out, you would end up over here, which would be several million meters away from the south pole of Minmus when Minmus got out here. Or if you brought it out over here, you'd be several million meters above Minmus' north pole when it got out to here. And so when we're talking about how to get to Minmus, understanding how to describe the orbital variables will help you get there. I have 3 flight plans that I want to describe to you of how to get to Minmus. And they all are using this stock PT Mun's Explorer that we used to get to Mun last episode. You can use a different ship, but I'm just using this one because it's stock and you don't have to worry about building a specific ship. This can get you just to Mun or to Minmus just fine.
The first flight plan is basically that we need to launch from the pad heading 90 degrees and get to a circular orbit. Then we make a plane change where we burn in the normal or anti-normal direction at the ascending or descending node to match a 6-degree incline of Minmus. Then create a maneuver node at about 930 meters per second of delta V in the prograde direction and rotate it around Kerbin until the closest approach with Minmus gives a flyby. Flight plan 2, we launch from the pad heading 90 degrees and get into a circular orbit. We create a maneuver node at the ascending and descending node with about 930 meters per second of delta V, and then we slowly add delta V until its closest approach with Minmus gives a flyby. We will overshoot, or we will most likely overshoot the orbital distance of Minmus by quite a bit, which makes it so that we spend a couple of days floating above Minmus's orbital radius, but on the same plane until Minmus comes into a flyby. Flight plan 3, where we time warp on the pad until we're just about to our ascending or descending node. Then we launch at a heading that's offset by about 7 degrees from 90 until we get into a circular orbit with a 6-degree incline. And then we create our maneuver node. So this is different from flight plan 1 in that we start off in the 6-degree incline with the right longitude of ascending node.
In flight plan 1, you're going to head up at a 90-degree heading, basically head directly east, and you're going to get into a nice circular orbit around the equator. Aim for about 70 to 100 kilometers in height. Okay, once we've reached orbit and we're in an equatorial orbit, which I've gotten pretty close to, you're going to left click on Minmus and select as target. You can also, from the rendezvous HUD on Flight Engineer, you can select a target and just select Minmus. Those both do the same thing. Here you can see the ascending node and descending node are 5.5 degrees off, and if you left click and bring down the anti-normal direction, when I clicked on the ascending node to create my thing, if you right click on the ascending node or descending node tags, you can watch the relative inclination change down to 0, and that means that you've matched both the inclination and the longitude of the ascending node on those two orbital orbits. Left click on the orange, and you can also plan out your maneuver for the second burn, and this shows the closest approach, as we learned in the Mun episode. And you can left click and drag this around until you get a flyby. If the approach looks like it should have been the same place, that means that you went too high with your apoapse. And you can just come out here and look. That's an appropriate apoapse height, is when you're pretty much matching the orbit of Minmus. I'll bring this out just a little bit more. There we go. And then now you want to drag this around until you got a flyby. In flight plan 3, the best that I've figured out how to do so far is make the orbit of Minmus and the orbit of Mun overlap as well as you can, and bring time warp so that the Kerbal Space Center is pretty much at those 2 points. And then when you take off, you're going to be heading so that you're headed up in the 6 degree, or if you're on the other side, down 6 degrees location. Now that's off of 90, and so that means that when you're on the pad and you start heading up, when you start doing your pitch over and you see that this says 90, you want to bring it up to 97 or down to 83. And that will make it so that you'll end up in a 6 degree inclination, and the longitude of the ascending node will match the longitude of the ascending node of Minmus.
For your homework, go check out the page on Minmus on the Kerbal Space Program wiki, and also go check out the orbital parameters explanation that I showed you on the longitude of ascending node page on Wikipedia.